Today's lesson is on exact values using the unit circle. So here's the unit circle. If you are interested in knowing why the unit circle is the way it is, or why or how to remember it in the day that you can't use a resource sheet. In this class you can use a resource sheet, but maybe at university, college, or trade school you can't. Just a reminder, there is another video. It is, just checking here, exact values, the why, or the history lesson, depending on what I called it online. A reminder that every single one of these coordinates is an X, then a Y, which is alphabetical order, which means when you access them using trig, it's cos theta or cos x, sine theta, also alphabetical order. So that means that we are going to have to use the quotient identities to find tan and cotangent, and the reciprocal identities to find any time I ask you for secant or cosecant. And in all cases, we are looking for the exact value, meaning that you are not allowed to have any decimal answers. We are looking for fraction answers. And I am doing a bunch of questions. I do want you to know that if you are accessing that history lesson, we'll be doing, just let me find it, we'll be doing these three questions again using the special triangles, which is also part of the assignment if you are asked to do an assignment for me. So I will be referring back to these with the other video lesson. So let's look at this. The unfortunate part of any of this stuff is that I'm going to have to refer back to slide number 2 every time so that I can look at the unit circle so that you know where I'm looking for the answer. So the first question is sine 60 degrees, and we're looking for the exact value. Now sine 60 degrees is basically asking you for opposite over hypotenuse in lowest form for a triangle focusing on your 60 degree corner. Now this has an actual value for you, and that value is off the unit circle. So the way you find it is you go to the 60 degree mark, and you've got two numbers here to choose from. The first one is cosine, the second one is sine. So we're going to choose this one and write it on the previous page, and we are literally done the question. The end. Now, if you type that into your calculator, you'll get 0.866 blah blah blah. If you type sine 60 degrees into your calculator, you'll likely get 0.866 blah blah blah. We want the exact value, so we want the nicest fraction. So now I'm going to take that red circle that I have here, and I'm going to move it around. In this case, I'm looking for cosine of 0. So that means I go to 0, which is right here, so 0 degrees, and I have to look at, my circle's too big, so I'm going to start again. I have to look at cosine. So cosine's one of these and sine is the other, and we have to refer back to this, and there we go. So that's our answer. Done. Next one, cosine 45 degrees. So we have to go to the 45 degree mark, which is right here, and we have to figure out which of these two is cosine, and cosine is the first one. Now this is one of the places where if you screw up and don't know the difference between cosine theta and sine theta, I'm never going to be able to tell because they're identical. I need to write root 2 over 2 sitting here. There is something about root 2 over 2 that I want to mention while I remember, and that is if you look in a back of a book, you may see this black version and this red version are exactly the same. If you type this into your calculator, you'll get 0.707 blah, blah, blah. If you type this into your calculator, you'll get 0.707 blah, blah, blah. If you type this into your calculator, you'll get 0.707 blah, blah, blah. Either one of these are okay because either one of these is a fraction. 0.707 is not okay because, especially with the blah, 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 it's not exact. So now we get to a challenging question, and that is the tan of 30 degrees. And if I refer back to my unit circle, there is no tan coordinate. There's only an x and a y representing cos theta and sine theta respectively. So this is where we need to figure out a replacement. And this is where we have to refer back to our trig identity sheet. So I remember that there is a quotient identity that replaces tan in terms of the friendly words, which is sine and cos. So tan 30 can be replaced with sine 30 degrees over cos 30 degrees. So I am going to access those two numbers and stack them. So if I go to the 30 degree mark, I have to take sine 30 degrees, which is 1/2, and I have to divide it by root 3 over 2, which is cos 30 degrees. So that looks like this. Now I could do a 4-level fraction, or I could do 1/2 divided by root 3 over 2, which I prefer. Then I can follow the steps of dividing fractions, which is 1 over 2 times 2 over root 3. This 2 is on the denominator, this 2 is on the numerator, so I get an overall answer of 1 over root 3. And very similar to 1 over root 2, there is a second answer. And if you want to know the whys behind that, I can tell you. Just ask me and I'll send you a little answer, or I'll talk you through it in class. But either way, this and this are the same. Actually, let's do it now. I think this is a short-ish lesson. There are math teachers out there who think that this answer is uncool, and the reason it's uncool is because roots in the denominator are not finished in their mind. So what you can do is you can times both top and bottom by 1, but a fancy version of 1, which is anything over itself. And the anything we choose is the thing that makes it uncool. Then if we multiply across the top, we get root 2. And if we multiply across the bottom, we get root 4. Root 2 can't be made to look any nicer. Root 4 can, and that's how this answer gets simplified and why these two are the same value. If I then do the same thing with 1 over root 3, which is considered the uncool, unfinished version, I can times by 1, which is anything over itself. I'm choosing the thing that makes it uncool. So the top is root 3, the bottom is root 9, and root 9 can be done, which is why those are the equivalents of each other. So you have the choice at this point whether to do this, because I'm not in the uncool department, or I don't like to think I am, but you may run into that problem in the future, or you may run into seeing this and you have this, or vice versa, in a back of a book or something like that when you're checking your work. For now, let's keep going. This is a problem. Cos is on the unit circle, but that number's way bigger than 360, which is why I told you that you should probably know that reference angle, coterminal angle business. So what I'm going to do with 675 off to the side or on my calculator is I'm going to minus off 1 complete rotation. And because I don't have a calculator handy, I better do it like this. So that's 5, 1, 3. So cos 675 is the exact same thing as cos 315 degrees. So this is, both of them are on the unit circle. So this is going to be an example of me just plucking it off. So I have to go to the 315 degree mark, and I have to find the cosine value. So the 315 degree mark, and I have to find the cosine value, and write that in its place. Forgotten what it is already. Positive root 2 over 2. Next question. So, negative 780 is off the unit circle as well, but if I subtract 360 degrees, it's just going to make it worse negative. So I'm going to add 360 degrees, which means it's less negative. And that's still off the unit circle, because the unit circle is 0 to 360. So I'm going to add another 360. So I'm just creating coterminal angles until I get to the point where it's on the unit circle. And negative 60 is still not on the unit circle. Some of you might be able to figure out that negative 60 degrees is on the unit circle. Some of you will want to just keep adding 360 until you are literally on the unit circle. So, sine 300 is find 300, find sine, so we can write down negative root 3 over 2 for that answer. And yes, the negative is super important. The other option is knowing that this is 0, so that if you go in this direction, which is counterclockwise, that's positive degrees. But if you go in this direction, which is clockwise, that is negative. So this one, which says 330, is negative 30. This is negative 45. This is negative 60. If you could do that mental math in your head. Next one. Let's move it over here for fun. And negative 330 is not on the unit circle. Some of you may be able to figure out where it is on the unit circle quite simply. I'm going to turn it into a positive, and that's 30 degrees. So if I look up sine negative 330 degrees, it'll be the same as sine positive 30 degrees. There. Check one more time. Sine. Sine is the second one. A half. And here we have a problem. Two problems, actually. First problem is that this is 450 degrees off the unit circle. We do know how to take care of that. So now we have secant of 90 degrees. So I can find 90 degrees on this, but I can't find secant. This is a reciprocal identity. So this is the same thing as 1 over cos 90. Translated, that is upside down of cos 90 degrees. Something you are not allowed to write is this. That's not even a thing. That 90 has to be right beside a trig word. So now let's get ourselves an answer. So we have to go to the 90 degree mark, and to get from this line to this line, we will need to write the upside down of cos 90. So here's 90. Cos is the first one. So I have to write the upside down of 0. So 0 is 0 over 1. The upside down of that is 1 over 0, and I hope you realize that 1 over 0 is undefined. You could possibly see an answer of infinity, just so you know. At this point, I prefer undefined. So we've got a couple more questions, same deal, and the fact that I have to build in radians. So I'll move some of these off to the side so I have some space to work, and we'll deal with one problem this time. 240 degrees is on the unit circle, so I don't have to do any green subtracting for coterminal angles, but I do have to deal with cotangent. So let's deal with that. Cotangent in quotient angle or quotient identities is cos 240 degrees over sine 240 degrees. Now, hopefully you remember the first time we used one of the quotient angle identities today, or quotient identities today, I wrote division sideways when it came to the numbers. I am going to do the same thing here. So, unit circle, 240 degrees, short memory, cos over sine. So cos is the first one over sine. So negative 1 over 2 divided by negative root 3 over 2. Negative 1 over 2 divided by negative root 3 over 2. So that's negative 1 over 2 times 2 over negative root 3. 2's will cancel out because one's in the numerator and one's in the denominator. Negatives will cancel out because two negatives when you're multiplying or dividing is a positive. So we end up with this as an answer, and I remind you that you may see this because of this uncoolness. All right, next one, 9, 10. So way back in the first lesson of trig, degrees to radians, radians to degrees, RAA, reference angles, or related acute angles, we dealt with the fact that we needed to make sure that we knew what coterminal angles were, and we dealt with the fact that maybe radians weren't your friends. There is an exception to the rule, of course, and that is if you can find radians on your unit circle, and this one's on there, you don't have to do any conversion. So I'm going to go to sine 2 pi over 3. So first of all, I need to figure out if 2 pi over 3 is anywhere on here. Yes. So 2 pi over 3 and 120 degrees are the same thing, just different units. And we need to, oops, wrong slide. We need to figure out the sine coordinate, and sine is the second one, so I'm going to write down root 3 over 2, and we're done. So there's a lot of thought process for perhaps a little bit of an answer. So sometimes lots of work, sometimes very little work, and a lot of it happens in your head. I am going to double check the unit circle for 4 pi over 3. There it is. And I know I'm not going to be able to access secant. Do you remember what happens when you have secant? You'll need to take your answer for cos 4 pi over 3 and turn it upside down. There's a dog fight in my backyard. So cos is the first one. So I'm going to have to take negative 1/2 and turn it upside down. And because I can, I need to make it look pretty. And the last one here, cosecant, that's going to be another upside down one. 11 pi over 4, not sure about that. Nope. So there is a way to take 11 pi over 4, leave it in radians, and deal with radians, but I'm going to do the conversion because it's my comfort level and it'll come up again. So if I take 11 pi over 4 and I times by 180 over pi, my pi's will cancel out. That'll be 495 degrees. So cosecant of 11 pi over 4 is the same thing as cosecant of 495 degrees. Problem is that 495 degrees is not on the unit circle, so this one's got a bunch of problems. So I do the coterminal angle thing, I add or subtract a rotation to put it on the unit circle literally, and I end up with 135 degrees. That is on the unit circle, cosecant isn't. So you need to remember that cosecant has a reciprocal identity. Reciprocal meaning upside down, and it's the upside down of sine. So if I can figure out sine 135 degrees and turn it upside down, I will be able to go directly to my answer. So 135 sine. 135 sine. So root 2 over 2. Turn that upside down, and I'm okay with that. But I do want you to know that that's another one of those uncool things, so I'm just going to go through again how to fix this for your future. The thing that makes it uncool is the root in the denominator, so I multiply both levels by the root. The top will just be a squashed version of what you've got, and the bottom is root 4. Root 4 can be done. And we can actually simplify this time and get that answer. There is a simpler way of doing it, and that is, if you remember, back to that box of information, this and this are interchangeable. So when you see this, if your brain tells you, oh, this is way easier to flip, then you can take this and flip it upside down. So either way, I will accept this answer and I will accept this answer. Your choice. So this would be the end of the note, except that I want to talk about the history of the unit circle, why the unit circle is the way it is. There's that extra video for it. So I need this as a comparison. So I'm going to put this here, and this here, and I'm just going to scribble here for a second and say that this is, we're doing this using the unit circle, because we'll come back and do a comparison at some point, not this video. So here's my unit circle. I need sine 30 degrees. So here's 30 degrees. Sine is the second one. So all I have to do for that one is write down a half. No biggie. Tan 120. 120 is on the unit circle. Tan is not. So I need to find 120 and steal both sine and cos in this order and plop them down. Sine, then cos, sine, then cos. So sine, root 3 over 2, cos, negative 1/2. And then we have to clean this up, so I'm going to multiply by the upside down. I can scratch out these 2's. Be careful that you don't let the negative vanish completely. And that's our final answer. And then the last one is 585. 585 is not on the unit circle, so I'm going to do my quick coterminal. That is on the unit circle. Cotangent is cos over sine. $225 cos then sine. 225 cos then sine. So identical values, both of them being negative. Now I hope you don't have to go through all this work. I'll tell you why in a second. Gone, 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 gone. 1's left behind, so -1 times -1 is +1. I hope you can go straight from there to there, because this is a value divided by the exact same value, and regardless of how pretty or ugly they are, that does result in 1. So that is the units, how to use the unit circle note with, my numbering was good this time, 12, 13, 14, 15 examples. If that isn't enough, or if I need to explain something in a different way, then please ask me. Also refer to the why the unit circle is the way it is, the history lesson. And the reason I say that is because maybe you will prefer the special triangle method. The special triangles are basically how all these numbers came about. All I'm going to do in the history lesson is to give you a way to remember this in case someday you don't have a resource sheet. So that is that. Sorry for bopping around there, and have yourself a nice day.